In the name of Allah, the Beneficent, the Merciful. Welcome to the world of physics. Due to coronavirus, we have to continue our online class. At first, I'd like to suggest you stay home, stay safe. Let me introduce. I am Muhammad Muqtadir Hussain Bhuya, lecturer, Department of Physics, and today we are going to learn about the chapter Semiconductor and Electronics. And this is our last lecture on this chapter. And this is the diagram. At first, observe this diagram, and I think all of you previously um, know this diagram. And this is a picture of transistor, and it's the application of semiconductor and electronics. And I think all of you can guess the diagram. And uh, after this class, in the end of this lesson, will be able to uh, explain all of these terms and topics, and these are non-positional number system, positional number system, decimal number system, binary number system, octal number system, and hexadecimal number system. And these all are actually all of these are the learning outcomes of this chapter uh, and of today's lesson. And we can convert a numbers base that is from one base to another base, and from decimal to another base, and some base to another base, and a shortcut method for converting binary to octal, octal to binary, and binary to hexadecimal, and hexadecimal to binary number fraction, and numbers in binary number system. And keywords for this lesson is uh, that is base, binary number system, binary point, bit, decimal number system, division, Riemann technique, and fractional number, hexadecimal number system, LSD, that is least significant digit, and memory dump, most significant digit, non-positional number system, and octal number system, and positional number system. These all are the keywords. I think all of you actually know all these keywords because you have a chapter in ICT that is same to our lecture. And we are also going to present all this content also, that is what is a logic gate, why it is used, and basics of logic gate, universal logic gate, universality of NAND and NOR gate, and exclusive logic gate, compound or complex logic gates. These all of the contents we are going to learn in this lecture. And at first, our first topic is number system. And we all know that number system are two types, that is positional number system and non-positional number system. In ancient times, uh, the ancient times people use this number system, that is non-positional number system. And in this number system is symbol represent the same value regardless of its position in the number, and it's actually difficult to perform the arithmetic with such a number system. And today, at present, we use this number system, that is positional number system, and use only few symbols called digit. And these symbols represent different values depending on the position they occupy in the number. And in positional number system, the value of each digit is determined by the digit itself, the position of the digit in the number, and the base of the number system. And the maximum value of the significant digit, maximum value of a single digit is always equal to 1 less than the value of the base. And here in decimal, actually we all use decimal number system, and we only use 10 symbol or digit, that is from 1 to 9 and 0. And we use this number system in our day-to-day life, and its base is 10. Now that is decimal number system. And in decimal number system, for example, the number is 2568, and we uh, know the position of this of all these digits, that is 1, 10, 100, and 1000 position. and we uh, multiply its digit by its positional value. That is 6 is unit value, and uh, uh, 8 is 8th 10th 10th position, and it is 100. 5 is in 100th position, and 2 is in 1000 position, and we multiply with their positional value, and after we get all these number, and some by adding all these values we can get this value, and here the base is 10, that's why we use 10 here. And in binary number system, it's also a positional number system, and here we only use two symbols or digit, that is 0 and 1. That's why here base is 2, and this number system is used in a computer especially, and all of you know that. And we can also represent binary number like 10101, and we can convert this in another number system, that is in decimal number system, by multiplying this in that way, that is by the position that it carried. And uh, here 2 is the base of the number, that is 10101, and after multiplying in this way we can get the number, and it is in decimal number system. And representing number in different system, that is from binary to decimal. Here to represent for binary for binary number system, that is base, here the base is 2 in left side, that is uh, uh, it is in binary number system, and here the base is 10, that is in decimal number system. Here a B stand for binary digit, and here a bit in computer terminology means it's either 0 or a 1, and a binary number consisting of n bit is called n bit number. And in octal number system, it's also a positional number system, and here the number is from 1 to 7 and 0, that is total 8 number, and here maximum value is 8, and here the base of this number system is 8. And from octal number system, we use from the digit from 0 to 7, and after and by here the example is given from to convert the octal number in decimal number, and here we multiply all these digits with 8 and their and by their positional value, and here after converting we get this value in decimal number system from octal number to decimal number system. I think I'm going a little bit fast because uh, uh, all of you understand the all of this conversion, because already you have learned this conversion in ICT. And here I'm also just recapitulating all these number system for you, just for reminding you that we also have these topics in our physics book. And here the hexadecimal number system is also a positional number system, and we use from 0 to 9, there is 10 total 10 number or 10 digit symbol, and from A to F. And here A stand for 10, B stand for 11, C stand for 12, D stand for 13, E stand for 14, and F stand for 15. Here maximum single digit value is 15, and we use F in hexadecimal number system for 15. And from hexadecimal number system uh, uh, to decimal number, we can convert this hexadecimal number to hexadecimal number uh, a decimal number system by multiplying these with the base, that is here the number is in hexadecimal system, that's why we multiply all this positional value with 16. Here 16 is for their uh, base of the number system, and by this we can convert a hexadecimal number to uh, decimal number. And converting a number of another base to a decimal number, here we use three steps. That is, step one is determine the column positional value of each digit and multiply the obtained column value by the digit of the corresponding column. And step three is calculating the sum of the all of these products. And for example, here actually previously we have converted such type of value. Here we use here 4, 7, 0, and 6 are the at, digits here, and we want to convert this value in decimal number system, and it's from octal value. That's why we use use uh, uh, 8 here, because our initial value of this number no, initially this number belong to octal system. And here 3 power 3 to 1 or 0 is column value, and column value by the corresponding digits. And after multiplying this, we can sum of these products, and we get the value in decimal number system. And we can convert a decimal to a number of another base. That is, we also follow three steps. That is, divide the decimal number to the converted to be converted by the value of a new base. And step two is record the remainder from step one as the uh, rightmost digit and least significant digit of the new base number. And step three is the divide the quotient of the previous divide by the new base. And here step four is record the remainder from step three as the next digit to the left of the new base number. I think it's a little bit clumsy to get all these steps here, but practically it's so much easy to convert any number. Here we have an example to convert a decimal number to another base, that is in octal base. And here we want to convert this in octal base. That's why we divide the value, that is 952 with 8. That's why we want to convert this value in octal system. That's why we divide 952 with 8, and here we get 119. That is the result. And here remainder is 0. And after getting the number 119, we also divide this with 8, and we get the result, that is 14. And here the quotient is 7. And here the remainder is 7. And we again we divide the value uh, 14 with 14 by 8. That's why we get a result, that is 1. And here the remainder is 6. And if you want to divide the value 1 with 8, that's why we don't get any discrete value here. That's why the result of the division is 0, and here the remainder is 1. And after getting all this remainder, we take this remainder from last digit to our first digit. That's here, and we take 1670, and here we write 1670. And here the base is in octal number system. And uh, here the basic concept is, if you want to convert any decimal number to another base, that's why you have to divide the number with the base and in which base you want to convert. And here the important thing is, here the remainder value is written in the right side. And at last take all the remainder values from bottom point to the upper point, and write in chronological way. to get the number in that positional number system, and converting a number of some base to another base, and here convert the original number to a decimal number system, and convert the decimal number system to obtain new base number system. By these two steps you can convert any of the number of some base to a number system in another base. And uh, here uh, here uh, we have consider a number that is 5 is here the base is 6, and we can convert if you want to convert this number in 4 base, and at first you have to convert this in decimal number system, and after that you have to convert this decimal number to that number. And previously we see that to convert this number in another base, and if you want to convert this number in 4 base number system, that's why we divide this number with 4, and by the same way we divide and we write the result here, and we if you get any remainder, then write this value in right side, and after that you take the value from bottom to uh, upper side, bottom to upper side, and write this value 3130. It is in 4 base, and here here our question is to convert a number from from a base 6 to a base 4, and finally by following these two steps we can convert a number from one number system to another number system. And converting a decimal number to a number of another base, I think it's very much easy for you to convert this number, and by following two steps we can convert the number from some base to another base. And here we get help from um, from any base to decimal, then we go into another base. And here is shortcut uh, method for binary to its equivalent octal number. Here we have two steps, and by following these two steps, here the example is here we here the number is given in binary number system, and then we convert this number in want to convert this number in octal number system. That's why we take 3 digits of binary number, and write the write the uh, position value of these uh, write the value of this 3 digit, and by putting this value putting this converting this value, we get the number 152, and it's in octal number system. Here the trick is, if you want to convert this in octal number system, then you have to take a 3 digit in um, a 3 digit accordingly, and then you convert this number to binary number, then you get from binary number to octal number, then you got the result to octal. Here if you want to convert this in hexadecimal, then we will take 4 digits of binary system accordingly, and then we will get a number in hexadecimal system. Here another example from uh, octal to binary, and here the octal number is 5, and we can convert this 5 like in binary, that is 101. And in reverse way, previously we see the conversion from binary to octal, and here the conversion is from octal to binary. And after converting these, we can write the value in binary number system. Here the shortcut thing is convert each digits, that is 2, 6 and 5, all these digits with 3-bit binary digits, and then write all these digits in chronological way, then we can get the number in decimal number system. And here the shortcut method for binary to hexadecimal. Previously, we also uh, discussed this. And here, here the first uh, at first we take 4 digits inside, and that is 1101. And here we have only two digit, and to make it in hexadecimal, uh, we just put 00 in left side to make it in 4 digit, and then we convert this value in a number system, and then we get the value, that is 3 and 13. And we know in hexadecimal number system, 13 stand for D stands for 13, and just we write the value uh, 3 and D. Here 0011 is 3, and 1101 is 13, and that's why we get the result in hexadecimal number, that is 3D. And in opposite way, we also convert hexadecimal number in equivalent binary number system. And here the method is given, steps are given, and we take 4 binary digit accordingly, and put their equivalent number, and finally we get the number in binary number system. By this way, we can convert a hexadecimal number system to binary number system. And uh, we have to here 2 is only 1 and 0. This value is 2 in binary number. Here we have to put 00, cause here we are going to convert this number in hexadecimal number system. That's why for every digit we have to write 4 binary digit, and if there is 1 or 2 binary digit, then we have to write one more 0 to the left side to any digit to make it a 4 digit binary number. And with this value, we can convert a hexadecimal number into binary number. And our next topic is logic gate. And we know there are three types of basic gate, that is AND gate, OR gate, and NOT gate. And all of you know the symbol of AND, OR, and NOT gate. And here the function of AND gate is A dot B, function of OR gate is A plus B, and function of NOT gate is prime, that is inverted value. And here the truth table is given, and here if the two input is 0, then we get the output is 0, and only if the input is 1 1, then we get the output is 1. And by putting this value in this equation, we also can get the output. And here in OR gate, if any one of the input digit is 1, then we get the result, that is 1. And in NOT gate, here the input is 0 and 1, and we get just opposite result in NOT gate. And we have two types of universal logic gate, that is NAND gate and NOR gate. NAND gate is nothing but not and NOR gate is nothing but not OR. That is, we previously we learned AND gate, and we have to put a prime here just to get the not AND, that is NAND gate. And it's here the output value of this NAND gate is just opposite of AND gate, that is in AND gate we get the results 0 0 0 and 1, and in NAND gate we have we got the result of opposite result of AND gate, and it is the output result of NAND, and it is the output result of OR gate. And here you have to keep in mind that NAND is nothing but not and NOR gate is nothing but not OR. NOR gate is nothing but not OR. And here the output value of NAND and NOR is just the opposite of AND and OR gate. And we have another three complex other explosive gate, that is a buffer gate, XOR gate, and XNOR gate. And XOR gate is also called uh, uh, XOR gate is also called exclusive OR gate, and it is exclusive NOR gate. And exclusive OR and exclusive NOR gate is just opposite. And here the function of exclusive OR is a b prime plus a prime b. And after putting this value of a and b in this equation, we get the output value here. And after getting the output of XOR gate, we put this if we put another NOT gate in forward to XOR gate, then we get the result of X NOR gate, and here the result is 1001. And here previously we have learned about logic gate and why it is used, and basic logic gate, universal logic gate, a universality of NAND and NOR gate, and exclusive logic gates, and compound or complex gate. And here logic gate is a basic is a building block of digital circuit with which takes two or more input and gives only one input based Boolean algebra. Use of logic gates, that is such devices as multiplexer, register, arithmetic logic unit, and computer memory, microprocessor, integrated circuit, discrete electronic components, and simple switches, and relays, and hydraulic, etc. And kinds of logic gate are four kinds, that is basic logic gate, universal logic gate, exclusive gate, and compound or complex gate. And previously we learned about AND gate, and there's a here AND gate is also explained in another way. Here the basic explanation of is same that we have discussed in previously. And we have two input, that is A and B, and one output, that is Y. And it is the explanation for AND gate. And with the Venn diagram, we can also show AND gate. Here A and B is two input, and finally A and B, that is the blue colored region is called AND of A and B. Here AND is nothing but uh, common region for A and B. And here waveform of AND gate of two input, that is here if we put the input A and B here, and then we finally got the result of output. And for three input we also get the result of and gate. Previously we only discussed about two input, and here three input and gate is also shown. And for only one results, one result is one output is one, and if all the input value is one, and other than for all the input values, we get the result zero for three input and gate. And our second basic gate is OR gate, and for OR gate if any one of the input is one, then we get the result, that is or that is one. And here the basic here the background thinking is, if any of the switch is on, then we get the bulb ignited here. If any of the input is one, then we get the result, output result, that is one. And here we can explain OR gate with this Venn diagram. That is if input is A and B, and output result is A or B, that is here the common region of in blue color show the or A or B region. And for two input OR gate, here the waveform of A and B is shown, and it's the result of two input OR gate. And if we use three input OR gate, and if any of the any of the input is one, then we got the output result, that is one. And here NOT gate is nothing but inverter, and complement work is used for complement work. and if the input is 1 then the output is 0, and if the input is 0 then the output is 1, and we use a bar or a prime to a prime or a bar for NOT gate. And here the NAND gate is a universal gate, and NAND gate is not AND gate, and for two input it's the opposite result of AND gate. And here previously we see that this is the region for AND gate, and uh, if we complement this region, then we got the we got the region that is for NAND gate. And here uh, except white region, all the region is for NAND gate. And here by using NAND gate we can convert we can get three basic gate. That is by using NAND gate we can get a NOT gate, and by using NAND gate we can get AND output, and it is AND gate. And we by using AND gate we can get also OR gate, and that's why NAND gate is also called universal gate. And universal gate, NOR gate is also universal gate. NOR gate is consist of OR plus NOT gate, and just opposite result of OR gate. In OR gate, we have this Venn diagram that is shown below. And if we complement this OR gate, then we get NOR. For the result of NOR gate, this Venn diagram is for NOR gate. And universality of NOR gate, and by using this NOR gate we get uh, NOT gate, OR gate, and AND gate. That's why NOR gate is universal. By using NOR gate we can get AND or and NOT gate. That's why NOR gate is universal gate. And we have also some exclusive gate here. The actually the word is exclusive gate, and exclusive OR gate. And here the truth table is shown, and this is the AB circuit diagram for exclusive OR gate. And the function is a b prime plus a prime b, or we can also write it as a b bar plus a bar b. And exclusive gate for exclusive, just opposite result of exclusive OR is exclusive NOR gate. And here the truth table and the diagram, and output result output function is of exclusive NOR gate is also shown. And here the truth table for exclusive NOR gate. And we also here it is a complex gate, cause it is and or and or invert. And if it is OR and invert, then it is called complex gate. And this is a Boolean rows for Boolean algebra. You can pause the video here and just uh, try to learn the basic rules of Boolean algebra, and with this we can simplify any of the function. And this is the logic gate, that is AND or NOT gate, or NOR, NAND, and XNOR. And symbol and truth table is also shown. And this is the AND or NOT gate, NAND, NOR, XOR, and XNOR gate is also shown here. And here few MCQ is shown here. Uh, it's up to it's your task to solve these MCQ here, and pause the video in a slide and try to solve these. And I'm going a little bit faster because it's your task to solve this MCQ. And pause the video here and solve these two questions, and again pause the video here and solve these two questions, two MCQ question. And here we also have two questions, and pause the video to solve these two MCQ. And here pause the video, you can pause the video here again and try to solve this CQ that is related to our topic. So here some of the knowledge base question is shown, and pause the video here and try to solve these knowledge base question. That is, what is band theory, what is conductor, what is semiconductor, what is insulator, what is valence band, what is conduction band, what is forbidden band. And some other knowledge base question are what are diodes made of, and is diode convert AC to DC, and what is the diode symbol, and some other question. And pause the video and try to solve all these knowledge based question, and it's up to you. And if you can solve all these knowledge based question, then it will be helpful for you to solve any type of question for your exam, I hope. And if you have any question, then ask me in our class time. I'm always available for you. And here the home task for you once again. And you have to be you have to solve all these questions by yourself and be conscious about coronavirus. And thank you all for joining with us. Stay with us. Thank you once again. Allah Hafiz.